Hello and welcome to this GCSE Science Revision videos for core physics on waves. In this video we'll be looking at waves, reflection, refraction and diffraction, and sound. Waves can be split into two main groups. In transverse waves, the oscillations or vibrations are at right angles to the direction of travel and energy transfer. Light and other types of electromagnetic radiation are transverse waves. All types of electromagnetic waves travel at the same speed through a vacuum, such as space. In longitudinal waves, the oscillations are along the same direction as the direction of travel and energy transfer. Sound waves and waves in stretched springs are longitudinal waves. P waves, such as seismic waves, are also longitudinal waves. Longitudinal waves show an area of compression and refraction. In the diagram below, the areas of compression are where the parts of the spring are close together, while the areas of refraction are where they are far apart. The amplitude of the wave is shown by the patterns of disturbance within the wave. So therefore, as a wave travels, they set up patterns of disturbance. The amplitude of a wave is its maximum disturbance from an undisturbed position. Take care that the amplitude is not the distance between the top and the bottom of the wave. The wavelength or wave is the distance between a point on one wave and the same point on the next wave. It is often easiest measured from crest to crest or trough to trough. The frequency of a wave is the number of waves produced per second. It is also the number of waves that pass over a certain point. To calculate wave speed, we use the following equation. Velocity is equal to frequency times by wavelength, where in the equation v is the wave speed measured in meters per second, f is the frequency measured in hertz, and the other symbol stands for lambda, which is the wavelength measured in meters. The equation can be rearranged to frequency is equal to wave speed divided by lambda, or lambda is equal to wave speed divided by frequency. Sound waves and light waves reflect from surfaces. When waves reflect, they obey the law of reflection. This is that the angle of incidence equals angle of reflection. So for instance, if the angle of incidence is 20 degrees, then the angle of reflection will also be 20 degrees. The normal line is drawn at right angles to the reflector. The angle of incidence is between the incoming ray and the normal, and the angle of reflection is between the reflected ray and the normal. Smooth surfaces produce strong echoes when sound waves hit them and can act as mirrors when light hits them. The waves are reflected uniformly and light can come to form images this way. They appear as points behind the mirror. So when drawing diagrams, you need to make sure that your sight lines go behind where you've drawn the mirror. Rough surfaces scatter sound and light in all directions. However, each tiny bit of the surface follows the rule that the angle of incidence equals the angle of reflection. The diagram shows how this can be drawn. When drawing one of these diagrams, it is important to remember to put arrows on to show the direction that the light is travelling. The plane mirror is also represented by a dashed line. Refraction is shown when sound waves and light waves change speed when they pass across a boundary between two substances with different densities such as air and glass. This causes them to change direction, and this effect is called refraction. There is one special case that you may need to know. Refraction doesn't happen if the waves cross the boundaries at an angle of 90 degrees, called the normal. In that case, they carry straight on. The diagram shows how to draw a refraction diagram. You need to draw two normals, one at where the incident ray enters the glass and one at where the incident ray exits the glass. When waves meet a gap in a barrier, they carry on through the gap. However, the waves spread out some extent beyond the gap. This is called diffraction. The extent of spreading depends on the width of the gap compared to the wavelength. Significant diffraction only happens when the wavelength is of the same order or magnitude as the gap. So, for example, a gap with a similar to the wavelength causes a lot of spreading with no sharp shadow. A gap with a much larger gap than the wavelength causes little spreading and a sharp shadow is formed. For instance, a light through a doorway acts in this manner. Sound waves are longitudinal waves that must pass through a medium. Echoes are reflections of sound. Light and other forms of electromagnetic radiation also travel as transverse waves. These waves can travel through a vacuum, however, sound cannot. Sound is dependent upon vibrations. When an object or substance vibrates, it produces sound. The greater the amplitude of the vibration, the louder the sound. The greater the frequency of the vibration, the higher the pitch. The diagram on the side shows how a compression wave passes through a medium that causes sounds. So remember, when revising, turn off any distractions. Remember, quality time is better than quantity of time. Keep asking yourself questions and start revising earlier in the day as your brain will be more active. Thank you for watching. Have a look at the other revision videos to help you with other sections in the physics core paper. Good luck with your exam.